that one in the recording who are present in this class. Okay, so um, for this week, uniform circular motion or UCM. Okay, so what is this uniform circular motion? First, we will deal with the kinematics. We all know in physics we have kinematics and dynamics. When we say kinematics, it's the branch of physics that deals with the description of motion. When we say dynamics, it's the branch of physics that deals with what causes the motion. So first, kinematics to describe the motion. So here in figure 5-1, it's taken from Jen Colley book. A small object moving in a circle, like there is a velocity 1 tangent to the circle. When I say tangent, that touches the circle at one point. Okay, so this is the direction of the velocity tangent to the circle at this point. This second point already the object has shifted its direction, but take note the length of the arrow is still the same. So that's why uniform, because it has the same speed, constant speed, but then it has still acceleration because it keeps on changing direction. As we all know, acceleration can be achieved by changing direction, by changing the magnitude of the speed, or by changing both. Okay, so here in this case, not the magnitude ang change, but the direction. So this is uniform circular motion. If the object is moving in a circle, either horizontal or vertical circle in a constant speed, but still there is an acceleration directed inward or towards the center of the circle. So here, this is the derivation. It requires geometrical math. If you're good in math, you can just relate this one. So determine the change in velocity or delta V for a particle moving in a circle. So let's, hello. Um, yes, is there a question, Russell? Hello. Do you hear me, everyone? Can you hear me?
Yes, sir.
Okay.
Yes, sir.
Yeah, can you see the slides?
Yes, sir.
Okay. So figure 5-2, determining the change in velocity. So here we have, let me use annotation tool. Okay, here we have point A, starting with point A here. The object has moved to point B, okay, in this case. And take note of the green arrows. This represents the vectors of velocities. So V1 and V2. And they are constant. And of course, there is a radius from the center of the circle. So this is point C here, center of the circle. And take note, there is a theta between this line from C to A and line from C to B. Okay, this is the line drawn towards the position of the object moving in a circular path. Okay, so as you see from the figure, there is theta or the angle. And we have this part of the circle, this curve is what we call as arc. Okay, so the length delta L is the distance along the arc, kining L nga straight line na siya from A to B. So this is the arc. And as you have noticed, if imo ning i-draw ang V1 and V2, okay, that connects their tails together. So this one here, you connect the tails together, V1 and V2, you will come up with a similar angle. So because as we all know, if you put it in here, so you come up with a similar angle with this delta theta, and it's in geometry that similar triangles have also ratios of sides which are equal. You can get the ratio with sides. And the difference, imo ni move together lang tails, and then you get their difference. So this delta V. So here, the delta V. So the delta V is achieved by V2 minus V1. Okay, in that case. So in this case, yeah, we will clear our drawings. So in this case, delta V is V2 minus V1. Okay, the second velocity minus the first velocity. Okay, so if you get this part here, okay, so you are getting the difference of V2 minus V1. So it's vector subtraction. If you have this V2 and V1, then you connect it to the line. So this V2 minus V1. Okay, so in other words, if you get the ratios of the sides, so kining delta V, mao ni nga side diri sa kining nga triangle, because we are dealing now with similar triangle, delta V over V wherein V is just the V1 and V2. Kay pareha man ni silang velocities, kay constant man ang speed. So we have V, they are equal. Okay, and then we have delta V over V and delta L over R. So kini delta V over V, the side. Okay, delta V over V, ini ang sign niya V1 of V2. And delta L, this one also, kini mo ni delta L sa dinhi nila. Okay, delta L. So here, delta L over the radius. So kabantay mo, imo rang ratio and proportion ang duha. Okay? So in that case, you have now the proportionality delta V over V, delta L over R. So this is just the derivation of the equation. No problem if you can really not grasp the geometry of it, but it's just derivation. Aron maka-remember ka when you discuss geom later that you deal with similar triangles. So delta V over V and delta L over R. And if you this one, the V, you're going to, shall we say, divide or multiply both sides by V, or you just cross multiply here. So the V will be here already, V over R and delta L. Okay? And we all know that since we are dealing with change in velocity, you can divide delta t both sides. Okay, so delta t both sides. So if you divide delta t both sides, this will become the whole thing of it will become acceleration, di ba? Change in velocity over delta times acceleration. And take note, there is now a v delta l. Okay, here r delta t. So if you are going to arrange that one, so it will be V over R delta L over delta T. So this one, delta V L over delta T. We all know delta L is distance or displacement divided by T. So this can become the whole thing kining delta L over delta T will become V. Okay, so therefore it will become V squared over R. So that's the derivation why the inward acceleration or centripetal acceleration is V squared over R, because this V is constant and this r is constant also. Okay, so that is why we have radial, because it's in the radius, towards the radius of the circle or center, or centripetal acceleration. So to summarize, an object moving in a circle of radius r at constant speed v has an acceleration whose direction is toward the center of the circle and whose magnitude is ar v squared over r, or ac. So it's v squared over r, or the constant speed there divided by the radius. So this is the centripetal acceleration or inward seeking acceleration. Okay? Nakuha ra yun sa napag-derive. Naka-follow ra? Students? Hello? Nakuha? Okay, Andre? Okay ra? Okay, so that's why we have this a v squared over r because of this derivation. Okay, and then so circular motion is often described in terms of frequency f, the number of revolutions per second, and the period t of an object revolving in a circle is the time required for one complete revolution. So the time is in seconds, or the period. This is, take note, is capital T to mean period. Kay kung small t ni, that's time. And since capital T, it's the time to complete one whole revolution. So one whole tuyok sa circle. So that's why ang unit ani is second per revolution. Unta. But the revolution is not a unit. So second lang unit aning period. And the reciprocal of it is 1 over f. So it's 1 over f, or the frequency. So when you say frequency also, it's the number of revolution per unit time. So the number of rev, or one revolution per second, for example. So that's why it has a unit also ang frequency of revolution per second. Okay, so revolution per second, or in other words, s over negative 1, s to the power negative 1 or 1 over s. Kay revolution is not a real unit man. And in physics, this is known as hertz. Okay, unit of frequency is hertz, hz, in honor of Heinrich Hertz. So here, uh, Example, an object revolves a frequency of 3 revolution per second. So, manay ang frequency. Then, each revolution takes 1/3 of a second. So, they are just reciprocal to each other. So, this one is unit niya second. Ang usa is unit niya is 1/2 or s to the power negative 1. Di ba? Pareha raman eh. So, this one or s to the power negative 1. And then, if you want to apply that one, the velocity or the speed and a centripetal acceleration here, distance is one whole complete revolution. As we all know, it's the circumference of a circle, di ba? 2 pi r. So 2 pi r ang whole circumference sa circle sa whole distance nga i-cover ana. So meaning 2 pi r na yung one revolution nga yung i-cover nga distance divided by the period. So 2 pi r over t. Okay? So that's uniform circular motion. You remember the equation, v squared over r, and this one, t is equal to 1 over f. Okay, so you can use that later. Okay, so there's a word of caution here. So in uniform circular motion, the speed is constant, but acceleration is not zero. Okay, why acceleration is not zero? In fact, speed is constant. Anyone? Why acceleration is not zero? Yes, Andre.
For it changes direction all the time, sir.
Okay, very good. It changes its direction all the time, so it has still acceleration, though the speed is constant. And that is why you use similar triangle to derive that one, v squared over r, which is the centripetal acceleration. Another caution, the direction of motion v, velocity, and the acceleration are not in the same direction. So instead, they are perpendicular always to each other. So this is the centripetal acceleration inward towards the center of the circle, and this is the velocity, and they are perpendicular to each other. Okay, as a result, the object is moving in a circular motion, uniform. So as well as here, the acceleration and the velocity are always perpendicular to each other. Okay? Okay. So here, example 5-1 in Jan Colley book, 150-gram ball at the end of a string is revolving uniformly in a horizontal circle, radius 0.600 meters, as shown in figure 5-1 or 5-3, katong previous atong example. Figure, the ball makes 2 revolutions in a second. What is its centripetal acceleration? So if this is the 2 revolutions per second, so this is what? Getting 2 revolutions per second. Inso man eh. So ang radius is 0.600 meters. So you need this 0.600 meter the radius, okay? And since you need the 2 pi r over t, okay, here, it takes a solution. If the ball makes 2 complete revolutions per second, then the ball travels in a complete circle in a time interval of 0.50 seconds. Okay, kay 2 revolution man in a second. So 1 revolution is per 0.5 seconds. So which is its period, t. Okay, ang period man na ang time to complete, ang 0.5 second to complete 1 revolution. So here, the distance traveled in this time is the circumference of the circle, and then the time elapsed, so 1 period is 0.5 seconds. So yun sa pagkuha sa 1 period kay 1 revolution in a second man na, or the frequency, so the period is there. Ang frequency ana kung kaon nimo it's 2 revolution in a second. Okay, so F. So ang F ana is 2 revolution, 2 rev in a second. So therefore your period is bali ana, di ba? So we have second per revolution. So kanang 2 revolution per second, so may mo nang 1 divided by 2 rev per second. So mahimo na na nga second ang diri sa numerator, which is 0.5 second. 0.5 second per revolution. So kini nga period nga 0.5 mo na ibutang nimo sa denominator. Okay? You proceed with the circumference, the 2 pi r, the 2 pi, then the radius. So you will have units of meter per second still, which is the constant speed. Okay, not velocity, the constant speed. There's no arrow in here, so it means speed. And then the centripetal acceleration is v squared over r, so you can automatically get that one by those values. Okay, so yun, di ba? Okay, so let's proceed to the next slide. Another example here. Moon centripetal acceleration. The moon's nearly circular orbit around the Earth has a radius of, money radius, ha? And a period T of 27.3 days. So, Messianic period is the time to complete one cycle. Okay? One whole cycle. So, determine the acceleration of the moon toward the Earth. So, we all know V squared over R. Okay? And pagkuha ka sa V, it's 2 pi R over period, di ba? So therefore, may mo ning 2 pi R squared, may mo ning T squared. Kay 2 pi R over T man ipuli ni mo dire, di ba? This one. Pulihan na mag 2 pi R over T. So this happens to the equation. It will become 4 pi squared R times period squared. So 4 pi squared, 3.14 ni, then R is given. You convert this to meters, aron maka-meter ka per second imong unit sa last per second squared. And then your time or your period from days you convert it to seconds. Kaya ba mo convert na in chem no? So i-dimensional analysis lang na one day is pila man eh? 24 hours. O 24 hours. Sakto? So
Yes,
mag-ana
sir.
din ka nga 1 hour is 60 minutes. Okay? Then after kag 1 hour sa pamanto, 1 minute is 60 seconds. So,
Second.
cancel lang minute, cancel lang hour, cancel lang day. Okay, there. So, that's a dimensional analysis in chem that you learn. So, there, you get this value of the centripetal acceleration of the moon, very small, 2.72 times 10 to the power of negative 3 meter per second squared. And if you write it as a factor of g, and you convert that one in terms of g, which is equal to 9.80, is just equal to 0.0003 g. So imagine, very small kaayo ang acceleration due to gravity sa moon. Dugay kay matagak ang object to the surface of the moon. Kay gamay kay sa acceleration due to gravity. Okay? So there. And gamay po kag-weight sa moon. Kay gamay mag-g. So that central acceleration of the moon is 2.78 times 10 to the power negative 4g. So very small. Or it's not the acceleration of gravity for object of the moon's surface due to the moon's gravity. Okay? So the centripetal acceleration dili na maoy acceleration of gravity for objects at the moon's surface due to the moon's gravity. Okay, centripetal lang na siya. Okay, centripetal nga dili na mo pa hulog sa object dahil sa moon. Centripetal meaning ang pagbira sa towards the center sa orbit. Okay, rather it's the acceleration due to the Earth's gravity for any objects is the moon, 4,000 from the Earth. Okay, so that's it. That's another example. Now let's proceed. Dynamics. When I say dynamics, it deals with the causes of motion. So what causes motion is force. So if you have centripetal acceleration, we have also centripetal force. And here it's easy because we know force is equal to ma. Ang a atong gamiton is the radial acceleration, which is v squared over r. So it follows that the centripetal force or radial force is mv squared over r. Okay? And this radial force and centripetal force is not a new kind of force. It's just the force na towards the center nga atong ngalanan og centripetal force. So like kung gravity, pwede na ang gravity mahimong cause of centripetal acceleration or centripetal force. So dili siya new force. It's the force nga naa na, but then it's center seeking such that it is centripetal. Okay, so here, that's mv squared over r. Okay, so here, like kini, nag-whirl ka around in a horizontal circle. Ang na-provide og centripetal force ani is that tension kay rope mana. So without the tension, if you cut the string here, dili mo circular ang motion, pero mo go straight lang by law of inertia. 'Di ba? Ingon to si Newton, the object will continue in its state of motion unless acted by unbalanced force. So kung mawala ning force here, mudritso na siya didto og straight line, dili siya mo circle. Okay? So it will go on in a straight line. So it's usually a favorite example in conceptual examples. Kung iputol daw ang string, asa mo pa daw ang ball. So it will go straight, dili siya mo padayon og circle. Kaya wala na may force. Okay? So there. Okay, next. This is now the illustration. Still, Newton's third law is existing also here. There is, you are pulling the ball inward, so through the string. So force on hand exerted by string. And similarly, force on ball exerted by string here. So kini, force on ball exerted by string, kini siya. And here, force on hand exerted by string. So, ang string po nag-exert of force on the hand. Ang string po nag-exert of force on the ball. So, swinging ball on the end of the string. So, naay giingon nga, if there is a centripetal force, there is a centrifugal force or center fleeing. Kanang mo oppose ani. It's not really an actual force. It's just like a reaction to the centripetal force. Kung naay padong diri nga inward, as a reaction to that by third law, naapoy padong outward. Pero it's not really a real force. Okay, so it's just a reaction to that. So if centrifugal force, the revolving ball would fly outward. If there is centrifugal force, so it will fly away from this part here. It will not follow a straight line kung napay centrifugal force. So mo fly away kung i-cut ni nimo, ang tendency nito sa ball mo padong adto. But it doesn't happen. Unsa may tendency sa ball mo adto dito. So there's no such thing as centrifugal force if you can read that one. As a proof kung naa kay kini sparks fly in straight lines. Awa kini mga spark kung nagtuyok nga machine, di ba? They will fly in straight lines. They will not move in a circle. Okay, they fly in a straight line. Okay, kung nagtuyok nimo sa kawan. So that is there an example. And another example here, force on revolving ball. Estimate the force of a person must exert on a string attached on a 0.150 kilogram ball to make the ball revolve in a horizontal circle of radius 0.600 meters. So there is a radius and akay masa ball. The ball makes 2 revolutions per second. So two revolutions per second is you can get the frequency and the period is 0.5 seconds. Okay, this already frequency man. Reciprocal of that is 0.5 seconds or the period. So if you want to know the force, so you all know the force is just ma by Newton's second law. Naman kay mass, so you can that and you solve na lang the a v squared over r. So you have 2 pi r over period ang v, and yeah, so this is 7.54 meter per second ang v. Mao na mo yung square. So 7.54 meter per second square time over the radius, it's around 14 newtons. So that's it. How to solve lang. MA ra. Just apply MV squared over R. And take note, when you solve a problem, you use the least number of significant figures. So this is constant, infinite number of significant figures. Kining 0.150 is tulo man ka significant figure. So supposed to be the answer is 1.50 Newton kay dapat three significant figures. Okay. So that's it in solving for the dynamics of circular motion. Another example, a vertical circle. In the last module of your K-hub, vertical circle siya. So as we all know, ang centripetal force is not really a different force but provided by gravity, provided by tension, or normal force. So kung vertical circle, makadrawing kag free body diagram here. Like in the bottom of path of the ball sa vertical circle, so it's tension and weight. In the upper part, it's tension still and the weight. And take note of the lines or the arrows. So here, a 1.50 kilogram ball on the end, a 1.10 meter long cord. So 1.10 meter long cord is swung in vertical circle. Determine the minimum speed the ball must have at the top of its arc. So kini top of its arc. And so that the ball continues moving in a circle. Calculate the tension in the cord at the bottom of the arc, assuming that the ball is moving at twice the speed of part A. So imo ko daw i-determine ang minimum speed dinhi such that ma-move gyapon in a circle ang ball. So take note, not necessary nga naaning duha pwede usaray naa. Okay, minimum speed man daw. So the approach, how to solve this one. The ball moves in a vertical circle and is not undergoing uniform circular motion. So kung vertical circle, wala nag-undergo uniform circular motion, kay lain-lain man sila amount of force based on this illustration. Okay? So the radius is assumed constant, but the speed v changes because of gravity. Okay, so nonetheless, equation 5-1 for this v squared over r is valid at each point along the circle. So valid gyapon yung v squared over r. And we use it at the top and bottom point. So the free body diagram is necessary. So I have told you, importante mag free body diagram. So kining mga pink arrows, these are the free body diagram of the ball on positions 1 and 2. So at point 1, two forces act on the ball. So what are these forces? Force of gravity or the weight, and the tension or FT or T. And here, both act downward. So they will add up. Okay, kini siya. And by to give it centripetal acceleration. So sila ang nakahatag og centripetal acceleration kini nga duha ka forces. We apply Newton's second law for the vertical direction. So we all know ang Newton's second law is ma, and the acceleration is radial or centripetal, so ma sub r. So choosing downward as positive since the acceleration is downward toward the center. So pwede ra i-downward yung mga positive diri tanan kay aron dili heavy cumbersome pag-handle sa calculation. So pwede ra imo lang i-choose nga downward as positive. Aron positive ra tanan imo i-deal nga value. So like here, FT1 and MG is positive positive. Pwede man negative negative. Yeah, you can do that as well. And also the MV squared R positive man atong kuan assume pa dong, so still positive here. Ang nag-provide sa centripetal force kay kining whole thing is centripetal force man is the tension and the weight. Naka-follow? So sila duha kay padung man sa center. Okay? So let's proceed. And if that one, from this equation, we can see that tension force at point 1 will get larger if V1 is made larger. Kung dako kaya ang V1, mo large ning FT. Kaya ang weight is constant man. Ang FT ra may mapungan nimo ang tension. Okay? Di ba? Ma-control. Ang weight, of course, because of the weight of the ball ra. But we are asked for the minimum speed to keep the ball moving in a circle. Unsa ba daw minimum speed? So the cord will remain taut as long as there is tension in it. So but if the tension disappears, so remain taut, circular siya, basta na tension lang. But pero if wala na tension, sa may tao sa bula, so mohotagak to siya. So but if the tension disappears, the cord can go limp and the ball will fall out of its circular path. So dili siya ma-circular. So that's the minimum speed will occur if T1 is equal to 0. So mo ni makaingon ka ang minimum di ay kana nga wala siya tension. Kay kung maka-speed na siya, kung na siya ibutang tension, so minimum kana nga point nga padung siya magka-tension. So the minimum is kuhaon sa nimong tension aron pag-solve ana. So to remove the tension or maka-solve ka, ang minimum force is kuha na ni plus FT but mg na lang, weight na lang. So is equated to F or the mass times acceleration. So you cancel out the mass, okay, you cancel out the mass there, and you can solve for V because you're asked about the minimum speed. So the minimum speed, therefore, if you solve it, yeah, transpose this one or cross multiply GR na ni. So V1 is square root of GR. Okay, so square root na siya. So there, G times R is acceleration due to gravity and the R. So 3.28 meter per second. Okay, square root. So this is the minimum speed at the top of the circle if the ball is to continue moving in a circular path. Okay? So when that's the minimum, gikuha lang ang tension. Gipili ng weight. And then here, when the ball is at the bottom of the circle at point 2, kung imo nung itan-aon katong point 2 ganina, the cord exerts tension upward whereas the gravity is downward. So there, atong ibalik ha. Uh, uh, Kini. Okay. Tension is upward, weight is downward at the bottom. So in this case, FT2 imong gi-up, ang minus mg is still acceleration due to weight downward man to minus mg. Ang kining centripetal force pa upward man padung man sa center circle upward so positive gihapon. So there, you are asked about when the ball is at the bottom of the circle unsa iyang tension. So you can solve this one kung ma-twice ayahang speed daw from the minimum, so i-twice na imong 3.228, may mo 6.566. Mo ni mo gamiton sa V. Okay? And over R, na magkay-radius, yan asag kay weight. So there, you can solve 7.35 newtons. Okay? So that is in a uniform circular motion, nga dili gyud uniform in a vertical circle, pero you can still use V squared over R there to analyze. Okay, so there is a conceptual example. The game of tether ball is played with a ball tied to a pole with a cord. After the ball is struck, it revolves around the pole as shown in figure 5-10, this one. In what direction is the acceleration of the ball and what force causes the acceleration causing constant speed? So in what direction is the acceleration of the ball daw? So response, if the ball revolves in a horizontal plane as shown, kini horizontal mani, the acceleration is points horizontally towards the center as we all know, kini. towards the center. And take note, inani man, tetherball man siya. So, dili siya ang iyang tension paana man. So, how come ma-center siya? So, take note, there is still weight. Di ba? There is still weight here. So, you can determine by the kuan, by addition of vector, di ba? Mag-parallelogram method man ka. Parallel pod ani, so parallel ana, so it's inward yun, this inward, okay, the summation sa tension ug ang weight, the by parallelogram method. So the vertical component of core tension balances the ball's weight. So kini ang vertical component, kung mag-component method ka ni balance ana, so ang horizontal component ra mabilin sa tension mo ay nag-give og kuan niya, nag-og centripetal acceleration or centripetal force. Or in other words, you can just do the parallelogram method. You can just draw the parallelogram method kana parallel ana, makadetermine mo nga ang diagonal niya is towards the center. Or by component method, ang Ty niya, ang tension in the Y component, gibalance ra sa weight. So ang iharang X component sa tension nag-provide og centripetal acceleration. Okay, so that's all for uniform circular motion and question so far. And there is a link there in your module 1, I think, to visit physics classroom. Yan na dito'y simulation, ma-affect ba ang mass sa centripetal acceleration, ang velocity, ang radius. You'll know, acceleration is v squared over r. Obviously, ang v raw ang r mo affect. So if imo tong i-move ang cursor dito, asa ang maka-affect sa velocity or acceleration, yung centripetal acceleration, maka-affect bang velocity or ang mass. So you can explore that one also. Okay, so question so far. Question. Naipangutana? Okay. Any question? Wala ra? Sayon ra. So are you ready for the quiz this afternoon? Newton's laws, applications. Hello. Ready ra mo? Question? Dili pa kaayo. Dili pa daw kaayo ready. So, kana sa man nato i-quiz, i-postpone na to tomorrow or karong hapon na lang. Andre, this afternoon, 3 p.m. to 5 p.m. Anyway, application. So, ang technique lang adto is free body diagram. And then, yeah, you sum up all the forces. If it's at equilibrium, static equilibrium kung rest, dynamic equilibrium kung constant velocity, you equate to zero. If accelerated siya, you equate it to ma by Newton's second law, mass times acceleration. And then if there are two unknowns, of course, you need two equations. So you can have the x component and the y component na summation. And you solve for the other. And of course, you use the trigonometric function, the sine and the cosine. Okay? Naipangutana? Okay. Alexis Zamora, in behalf of your class, some concerns? Hello? Any concerns so far? Okay, wala ra. Okay, so shall we pursue with the quiz this afternoon at 3 p.m.? Okay ra? Yeah, nobody voted yet on whether we or not we should postpone it. Nara?
No.
Okay. Tomorrow, yes, tomorrow, Maribel. Tomorrow. Do you like the quiz to be tomorrow? Yeah. So tomorrow, 3 p.m. to 5 p.m. Okay. Kung na mga questions, you can just email me. Okay? Or, yeah, so i-chat lang. Okay? So, if no more questions, so thank you for coming. And just message me if, yeah, if there are a lot of questions in your mind. And the quiz will be 3 p.m. to 5 p.m. tomorrow. Okay, thank you.
Thank you, sir. Bye,
Okay,
sir.
goodbye.
Bye, sir. Bye, sir.